Hi guys, Jerry here. So I will be presenting my final projects. So start, I will introduce the data source. The data we use for exploration is obtained from Kaggle, which contains wholesale price for King County, including Seattle, by covering homes sold between May 2014 and May 2015. The dependent variable is housing price, and the rest dependent variables include both numerable variables such as the size of living room, as well as the categorical variables such as house rating grade, and other variables are listed here in the description. So the first question is how to describe the overall housing market by using descriptive statistical analysis, including outputting the mean, standard deviation, minimum and maximum values of each independent variable. Among 20,000 observations, the average price is 540,000, and the listed houses have averagely 3.37 bedrooms and 2.11 bathrooms. There is no missing values and outliers. On the right side is a histogram of the price, which is an obviously left bias distribution and does not obey the normal distribution rule. And second question is examine how the independent factors may impact the house price. To examine that, I first calculated the correlation coefficient between the independent variables and target variable, price, and scatter plots are made for visualization. Based on the analysis, it can be seen that all the independent variables appear to have positive correlation with house price. Among them, the variables, the square foot living has the strongest correlation, followed by grade, square foot above, and bathrooms. These three variables have correlations with house price greater than 0.5, indicating that these variables have a strong positive correlation with price. To establish regressions, the data are split in the ratio of 70 to 30 for training set, and the test set. And the R-square as well as the mean squared errors are calculated. For the training data, the R-square is 0.607, and for the test data set, it's 0.582. There is little difference between the R-square of the training data set and the test data set, which shows that the prediction performance of the model is stable, but the R-square of the model is only about 0.6 overall, which shows that the model can only explain 60% of the variance ratio, and the performance of the regression model is relatively bad. So the next question is, can clustering tell us the different impacts of factors at different levels? By using the k-means cluster model, the larger the index is, the closer the class itself is. The more dispersed the classes are, and the better the clustering result is. From the above results, the clustering performance of the selecting three clusters is good. From the average price of these three categories, category 2 can be defined as luxury houses. Category 0 can be defined as medium level houses, and category 1 can be defined as low level houses. Linear regression are also performed for the three clusters separately. The R-square for group 1 is the highest, which is 0.4398, compared with the regression model including all data that has R-square of 0.6. After the samples are divided into three clusters, the R-squares of the three sub-models appear to be far less than 0.6. This shows that for this data set, clustering and dividing samples to separate modeling does not significantly improve the model performance, but reduce the prediction performance of the model. This is also due to the limitation of the data that we choose. All right, that's all for my presentation, and thank you guys.